Hello students, welcome to Interconnecting Physics. Today in this video, I will teach you some useful tricks to solve numerical problems on combination of resistors, and today we are going to use potential method. So without wasting time, let's get started. For regular updates, you can follow me on given links. So in last video, we did very simple numericals based combination of resistors. Now in this video, we are going to solve some complex network problems. So numerical number 1, find the equivalent resistance between the point A and B. Now remember some points here. Number 1, if we have wire AB and if in this wire there is no element present, that is no resistor, no capacitor, no inductor, no battery, okay, in the wire there is no resistor, no capacitor, no inductor and no battery, then we say potential at A is equal to potential at B and there is no potential drop across this wire, okay. And if there's some element present between the wire, whether resistor, capacitor, inductor or battery, then we see there is some potential drop, okay. So now using these points, let us understand this. This method is called as potential method. Now we have to calculate the effective resistance, that is equivalent resistance between point A and B. Let us calculate. First of all, draw some false battery, fictitious battery between point A and B. This is the first step in order to solve such problems. This is positive terminal, this is negative. Point A is at positive potential, point B is at negative potential, okay. Now from here to here, there is no element. Wire is straight, so that means point A will come here, okay. Now from here to here, no element is present, so there will be no potential drop. So that means this A will come here and there will not be any potential drop across this wire, okay. Now from point B, from here to here, there is no element present, so that means no potential drop will be here and point B will come here. So means negative potential will be here. So from here to here, there is no potential drop across this wire, so point B will come here, okay. So let us draw the diagram A and B. So let us draw the equivalent diagram, point A and point B, okay. So point A, from A to B, this R, from A to B, R, this R, okay. Again from A to B, B to A or A to B, one and the same thing, this resistance, that is R. Again from A to B, we have two resistors which are in series, okay. So R and R, this is R, this is R, okay. Again A to B, R, A to B, R, B to A, B to A, R, and A to B, two resistors which are in series, R. So equivalent diagram will be R, R and R are in series. So answer is 2R, okay. So this is point B, this is point A. So let us calculate equivalent resistance, which is R equivalent is equal to 1 over R plus 1 over R plus 1 over 2R. So LCM is 2R. So 2 plus 2 plus 1. Answer is 5 divided by 2R. Okay. So this is 1 over R equivalent. So that means R equivalent will be 2 divided by 5R. Okay. Now next problem, numerical number 2. Find the equivalent resistance between point A and B. Again, first step, to draw a fictitious battery between point A and B. This is positive, this is negative. So that point A is at positive potential and point B is at negative potential. Now from here to here, no element is present. So that means no potential drop. So A will come here. Again along this path there is no element present. So no potential drop. Again point A will come here. Okay. Now from B, this point to this point, there is no element. So point B will come here. Again from this to this, no element is present, point B will come here. Again from this to this, no element is present, so point B will come here. Here positive potential, here negative, negative and negative. Okay. So let us draw equivalent diagram between A and B. Now from A to B, this R. Let us draw R. Now from B to A, this R. From B to A or A to B, one and same thing. Now A to B, this R. Okay. Now these three resistors are parallel to each other. So answer will be R equivalent equal to R divided by 3. I have already told you, if same resistors are parallel, then answer is R divided by N, where N is number of resistors. So here 3 resistors. So R divided by 3 is the answer. Now come to numerical number 3. So again, let us draw the battery, fictitious battery between point A and B. This is plus, this is minus. So point A is at positive potential, point B is at negative potential. Now what does this symbol mean? What does this symbol mean? This symbol means this wire and this wire are not touching each other. Okay, they are not crossing each other, they are not touching each other. Okay, so we move from here to here, there is no element, so no potential drop, so point A will come here. Again from here to here, point here, there is no element, so no potential drop, so point A will come here. Again from this path, there is no element, so point A will come here. Again this path, there is no element, so no potential drop, point A will come here. Again this path, there is no element, so no potential drop, point A will come here. So positive potential here, same potential, because there is no element present in between this path. Okay. Now move from here to here, no element, so no potential drop, point B will come here. Again from here to here, there is no element, so no potential drop, point B will come here. From here to here, no element, point B will come here because no potential drop. Again from here to here, no element is present, so no potential drop will be there. Again here to here, no element is present, so point B will come here. Again from here to here, no element is present, so point B will come here. Okay. Now from A to B, let us draw the equivalent diagram. So this is point A because no element is present. This is point A because no element is present. So between A and B, this R, let us draw R. From B to A, this R, let us draw. Now from B to A, this R, let us draw. Now these three are parallel. So R equivalent will be R divided by 3. Now numerical number 4. Okay. Let us do this. A to B. Again A to B. You see A to B. These two are in series. Okay. Let us draw R, R. Now A to B, R. A to B, two are in series. Okay. This is very simple numerical. From A to B, we have to calculate equivalent resistance when we see this path, R and R in series. Okay. Again, diagonally, R is there. Again, if we move from this path, R and R in series, so we can draw. So, equivalent diagram will be R plus R is 2R. This is R. This is R plus 2R. This is R plus R is 2R. So, point A and B. If we calculate 2R and 2R, they are in parallel. So, answer will be 2R divided by 2. Answer is R. Okay. So, R and R. This is A, this is B. Okay. You understand? This 2R and 2R are parallel. So, answer will be 2R divided by number of resistors, that is 2. 2 cancels out with 2 and answer is R. So, this R and this R are parallel. So, answer is R divided by 2. Okay. Now, numerical number 5. Let us calculate. So, you see here, again, we need not to draw battery again and again. A is at positive potential and B is at negative potential. Okay. from A to this point. From A to this point. Let us say this point is from A to this point. There is no element, so no potential drop will be here, and this point will be A. Okay. Again, from B to this point, there is no element, so that means no potential drop, and point B will come here. So B will be at negative potential and A will be at positive potential. Now from A to B. Now from A to B, this R. Let us draw this R. Okay. Now from A to B. From A to B. Now this symbol means these two wires, this wire and this wire, are not touching each other. So this means these two are in series. Let us draw R, R. Okay. Now from A to B, this. Let us draw. Now this diagonal R and R are in series. Let us draw R and R. Okay. This is point A, this is point B. So these two are in series. So let us draw equivalent diagram. R, 2R, because R plus R is 2R. Again R, again 2R. Okay. This is point A, this is point B. Now this 2R and 2R are parallel. So answer will be 2R divided by 2. Answer is R. So let us draw this R. Answer of this and this is R and this is R. Okay. So these three are parallel. So answer is R divided by 3. Because in parallel combination, if we have same resistors, then answer is R equivalent equal to R divided by N, where R is the resistance of each resistor and N is the number of resistors. So answer is R divided by 3. So let us do this. Again, these two wires are touching each other. The difference between this numerical and this is, here these two wires were not touching, but here these two wires are touching. So again, potential method, if this is at positive potential, this is at negative potential, then if you move from here to here, then we see there is no element, so no potential drop, point A will come here. There is no element, so no potential drop, point B will come here. Okay. Now let us understand this situation. This, you see here, when we move here to here, let us say this is point O. Okay. When we move from here to point O, we see these two are parallel. These two are parallel because here current is dividing in two arms. These two are parallel. These two are parallel. Okay. This R and this R, because here two wires are touching. So this R and this R parallel. This R and this R are also parallel, and these two are in series. Let us draw equivalent diagram. A and B. From A to B, this R. Now this and this parallel. So let us draw R, R. Okay. These two are parallel. R, R. Okay. And this is point O. This is point O. Now from A to B, this is R. Okay. So these two are parallel. So answer will be, the answer will be R by 2. Okay. And answer is R by 2. These two are in series. So answer will be R by 2 plus R by 2, which is R. Do you understand? R and R are parallel. So answer will be R by 2. R and R are parallel. So answer will be R by 2. Now these two are in series. So answer is R. So that means equivalent circuit will be R, R and R. Point A, point B. And these three are parallel. So answer is R divided by 3. Okay. Now next problem. Let us understand this problem. Now if A is at positive potential and B is at negative potential, then if we move from here to here, no element is present, so point B will come here. Here to here, no element is present, so point B will come here because there is no potential drop. Again, no element is present, no potential drop, so point B will come here. No element is present, so point B will come here. Okay, so let us draw the equivalent diagram between point A and B. Point A and B, this. Point A and B, this. Point A and B are, again last point A and B. Okay, this are this. Okay, these four are parallel, so R equivalent will be R divided by 4. Okay, now next problem. Point A. Let us say point A is at positive potential, point B is at negative potential. Now, when we move from here to here, you see no element is present, so no potential drop, so point A will come here. No potential drop here, so point A will come here. Okay, but what about this point? Let us say this point is X. Okay, because here is potential drop. When we move from this to this, R is present, some element is present, so there will be some potential drop. So here there will be some different potential than potential at A. Okay, so let us say this point is X. Whether we move from B, whether we move from A, there is some potential drop, and potential at X will be different from potential at A and potential at B. So from A to X. From to A to X, this resistor. Let us draw R. From X to A, this resistor. Let us draw. From X to R, this resistor. Let us draw. Now from X to B, this resistor R. From X to B. Okay, these three are parallel. So answer is R by 3, and this is R. Now this R by 3 and R in series, so R equivalent is R divided by 3 plus R, which is R, plus 3R divided by 3. Answer is 4 by 3R. Okay, so this was all about today's video. So this was potential method, that is, if some element is present over the wire, then there will be potential drop, and if there is no element present, then there will not be any potential drop. So thank you very much. Don't forget to like, share and subscribe. Stay happy, stay healthy.